Hello, this is section 4.2 polynomial functions and models. So graphs of polynomial functions. So we talk about a little bit about polynomial in section 1. And then now we're going to talk about polynomial graph. So now this is the general forms of the polynomial. Okay. So we talk about that being a polynomial, the degree of each term must be the whole number. All right, in polynomial, there is a turning point. So what are the turning points? These are the turning points. Okay, so which is the graph turns at -2 and the graph turns at 2. So when they talking about graph turns, we talk about x value. So at the beginning, graph was actually the increasing up to 2, and then from the -2 start decreasing up to 2, increasing up to -2 and start decreasing up to 2, and then from the 2 it start increasing. Okay, so that's the turning point does. And also in end behavior, so we're talking about end behavior of the place of the here, the end behavior. All right, so when you look at the error on the both sides of the graph, we can find out the end behavior. So end behavior happens to be the either when x approaches the positive infinity and x approaches the negative infinity. And then we can just say about what does the f of x do, okay, which is a y value. So, all right, so let's look at the next page. So constant polynomial functions. So when we have a constant polynomial functions, which is slope is a 0 this time, which is a degree is a 0. So graph is a horizontal line. There's no x-intercept except the line goes through the x-axis. So and then you always get the 1 minus 7 here to here for this the functions. Okay, so that's a polynomial, which is the 0. The slope is a 0. And the linear function, which is we call the f of x ax plus b, or mainly you know about the y equal to mx plus b. It's the same as ax plus b. And then this is a line. And also there's a one x-intercept, and then there's no turning points because this is the only way to be increasing or decreasing. So that's we can say the slope is a negative positive by the m. Okay, so end behaviors are always going to be when a is a positive, and then this is actually one side is the when a is a positive, so the end behavior is f of x is actually when x is approached to when x is approached to the x approaches the infinity, which is f of x approaches the infinity, go together, and the x goes to negative infinity, and then f of x goes to negative infinity. And then when the a is less than 0, also about this way. So when x is the approach to infinity, and then y is, goes to negative infinity. When x goes to negative infinity, y goes to positive infinity. Okay, so that's the directions. Okay, you'll see from the end behavior. The quadratic function is gonna be the power 2, which is this one. So that's the main thing. So if you see the square is the largest degree, that's a quadratic function, which is a degree of 2. And then, excuse me. And then we'll get the parabola always. And then a is a positive upward, a is a negative downward. Graph can be a 0, 1, or 2. Has a x-intercept, 1 or 2 or none. Okay, 0 means none. And then there's exactly one turning point called the vertex, which is this is actually turning points. Okay, so parabola start from the parabola, we start having the turning points. And then when we have a cubic function is degree of 3, degrees of 3. And then since the degrees of 3, you might have 1 or 2 or 3 x-intercept with a 0. There's a 0 always, and then 2 turning points. And the end behavior, the same thing as the linear function. So a is a positive, and the end behavior goes negative infinity on the left and the positive infinity for the right, and NBA is less than 0, and the NB here will be the infinity to the left and the negative infinity to the right. So opposite directions. Okay, so as you notice here for the first graph, I already knew that this is a negative because when x is equal to positive infinity and the y is a negative infinity. See the different ways, right? X is equal to negative infinity and then y goes to positive infinity. And then I know that the a is a positive for this one because when x is infinity, same direction is a positive infinity. X goes to negative infinity, y goes to negative infinity. So okay, I want you to guess. So a is a positive or negative? This is actually positive because x goes to positive infinity, y goes to infinity, and the x goes to negative infinity, y also goes to negative infinity. So that's the direction. It's the same as the 1 and 3. Well, of course, it's different function, but it's still the cubic function. Now, there's another function we can call the quartic function, quartic polynomial functions. Oh, they're missing words, okay. Functions, okay. So if f of x equal to ax to 4 plus b. So what do you know because of the power 4? So it's a degree of 4. So this time, you might have up to 4 x-intercept and then up to 3 turning points. So when you think about the x-intercept, the y-intercept, so max numbers of the intercepts, x-intercepts you can get, which is same as solution, will be the same number as the degree of the polynomial, and the turning points are always one less than that. Okay, so yeah, these are the turning points, turning, and this is not really turning, but this is turning. And this turning turns it and turns it, okay? All right, and then quintic functions, which is a degree of 5. And then the same way as any of the odd the degree. So same thing as here, okay? All right, so let's look it up. So degree and x-intercept and the turning points. So graph a polynomial of the degree n, which is n is greater or equal to 1, has the most n x-intercept and n minus 1 turning points. Okay, so analyze the graph of the polynomial. So if you look at the idea here, right? So yeah, that's actually so when we have the even degree, always n here goes the same directions. So in the case, this is a is a positive, and this is a case of a is a negative. But when you have an odd function, which is yeah, so in here, so a is a positive means well this side's up and the left side's down, and then a is a negative, it's size right side's down and then the left side's up. Okay, so that always happens. Okay, all right, so let's look at the real problems. So when we get to the real problem, use the graph of the polynomial the following. So the a, so this one as a most of the degree, I want to say the degree could be at least the degree I can say is a 4. Okay, at least the degree. It could be higher, which is going to be a 4. And then because n here goes the same directions, so I want to say a is a positive, you know. And then there are the 4x in a set, which is a 4 solution. So that's why I said that the listed degree of 4. Okay, so the A, determine the number of the turning points. The turning points are, in this case, turning points comes with this one and this one to this one. So I want to say 3 turning points for this one. So there are 3 turning points. And then they're asking for the x-intercepts, which is there are 4, which is from here, which is -4. -4, and also here to here to here, and then if I write down, it'll be -2 and 2 and 3. So those are the x-intercept. State whether leading coefficient A is positive, negative. So I already knew because n behavior, which is n behavior is this place, okay. And the n behavior is gonna be both are the when x goes to infinity and f of x goes to infinity, when x goes to negative infinity and y f of x also goes to infinity, that's the case, a is a positive. So this different the minimum degree because of the n here goes the same directions. So I want to say the minimum degrees of 4, and then it could be higher. Okay, all right. So let's look at the next problem. Now we have actually the function with a graph this time. So in this case, So identify the x-intercept. So x-intercept is going to be here to here to here. So I want to say -2, 0, and 2 for the x-intercept. Approximate the coordinates of the any turning points on the nearest hundreds, which is we just need to actually guess right. But since we have a function, so this if you can use the decimals. You can use decimals to see better actually, okay? But I'll do my best on here. So the turning points are, on this case, is going to be this and this. Okay, so if I checked it out, so I think the x is about, it says a negative 1.15. And then if you look at the y value, it's a little bit more than 3. So I want to say 3.08, which is you plug it in negative 1.15 into the function to find the 2. And also there's another one, which is a similar place, right? It's a symmetric, right? With the, I think this is symmetric with the origin. So it's going to be positive 1.15, also negative 3.08 is another turning point, okay? Use your turning points to approximate any local extrema. So local extrema actually from the turning points, which is you have a local maximum is always a y value, okay, as a turning point, which is 3.08, and then local minimum value, same as a y, lowest place negative 3.08. All right, let's look at another problem. Now we have a function. So f of x is 3 minus 5x plus 2x cubed minus 1/2 x of 4. So the expression writing into the ascending power. So give the degree. So degree is always from the highest power. So highest power I can see is a 4. So I can say 4 is a degree. And also the leading coefficient is always comes with the leading term, which is the degree of 4. So the leading coefficient is this whole thing. So you have to put the negative with it and a half. And then also state the end behavior of the graph. So end behavior means you have to just look at the arrows. So what happened? It goes down, right? So how do you say that is when x goes infinity, I'm talking about this, and then f of x goes negative infinity. And then when x goes negative infinity, which is destruction, and then f of x goes negative infinity. Okay, so you can just say, so if you want to say that the graph falls on both sides, both ends, okay? Alrighty, okay, let's look at another one. Example 4. Evaluate f of x equal to -3, -2, 1, and 2. So now this is actually this function is we call the piecewise defined function. So which means each of the piece you have a different graph, okay? So between the -3 and -2 you have the 2x minus 1 function. Between the -2 and 1, you get the 1 minus x squared function. Between the 1 and 3, you got the x cubed functions. So when you're looking up each of the value of x here, right, you need to use a right equation. So I want to say -3 belongs to this first interval. -2 belongs to the second interval because there's an equal sign here. And then 1 belongs to the second equation because equal to 1. And then 2 belongs to the third equation. So in order to find the value of each of the x value, you need to put it into the right function. So if I'm looking for the value from -3, I have to use a 2 minus x, which is a -3 equal to 5. So that's a y value. In order to find the -2, now I have to use a second function. So x is now -2 squared. So it becomes a -3. Then in order to find the 1, I have to use the second functions again, which is a 0. And then if I'm looking for the value from the 2, use a cube, the third function. So 2 cubed equal to 8. Okay, so that's how you find each value from the piecewise defined function. So, and then sketch the graph of function, determine if the function is continuous, is a domain, and solve f of x equal to 0. Okay, so let's look it up here. So on the so I want to actually divide the regions, which is -4 to -2. I have first functions. I'm gonna put the first function graph here, and then between the -2 and 2, I'm gonna get the second function graph in here, and then between the 2 and 4, and then I'll get the graph of 3. Okay. So what you need is, okay, we only gonna use a -4 to -2 because there's a 2 endpoints. Okay. So in order to find the f of -4, I have to use the first function. So 0.5 times -4 square. So I get 8. So -4 is 8. So right here. And then of the -2, I have to use a first function too. So 0.5 of -2 square, which becomes a 2. So it's a -2 is a 2, but it's a close, okay? But it's a parabola, so you need to make it nicely curves, so curves. It's not straight, okay? So it makes the curves. And then also now I have to use a -2 and 2 even though it's not equal to. So if I use a -2 again, but you have to use the second function, which is a -2. But this time, 2 and -2 is open. So but this already -2 and -2, so it's open. So you have to open right here because it's not closed. One point should be closed on the vertical, the drops, okay? And the f of 2 come out as a 2, which is open too, so open. But this is a linear function, so make it straight. And then f of 2, which is a closed for this one, right? So 2 squared minus 4 equal to 0, which is right here. And then f of 4, which is the closed 2. So 4 squared minus 4, 16. So actually 12, right? So 4 is a 12 right here. And then this is also parabola. So make it nicely curved. Okay, it's curved. And then also asking for the f of x equal to 0, which means where is the 0? So this is the zeros, okay? All right, so which is your value will be the f of x equal to 0 in which x? So x equal to the 0 and 2. Okay, so this is solutions. Alrighty? Okay, let's look at the next problem. Okay, so in the next problem, oh, it's the same problem, so I don't know why I have two copies, okay? So I'm done with this one. Alrighty, okay, thank you for listening.